Am I live? Okay. I think I'm live. Let me check. Let me refresh this. I think it's behind, but I think I'm live. Let me know this. Says I'm live. I've got the chat here, so hold on. Am I live? Surely I should be live. No, surely. Am I live? Let me check on my phone. I think I'm live. Sorry guys, I'm just checking. Sometimes this takes long to. So I'm just there's an ad because my laptop is not telling me I'm live. No, you're not live. That means I'm live. You guys are funny. Alright, cool, cool, cool. All right, fair enough, fair enough. Okay, cool, cool, cool. I'm live, I'm live, I'm live. All right. So before I start, I just want to just say, hope you guys are doing well, and hope paper one went well for you. So yeah, paper two is tomorrow. How are we feeling? We feeling good? We feeling confident? Let's see. What's up, Darren? I'm good, man. How are you? Please do hard questions. I think I've got a couple of questions that are hard today. So yeah. Also as well. I watched when I was doing the timestamps for the last live. I saw that I made a mistake. Obviously, I saw it when I did it, but you guys are so funny telling me I'm too locked in. I think I was. So what I've got here is I've got my laptop here. Let me just where's this one I'm looking for? The live stream. All right, cool, 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 cool. Yeah, I've got this here. This laptop is from the archives. This one right here. This is from the archive. So I've got this here so I can see your chat. So if I make a mistake, then you guys I'll see it straight away. Right? All right. So we're gonna start. Anyways, let me get it up here and then we're gonna do these questions. I'm gonna see if how many I can get through, right? It's gonna be maybe around an hour and a half, 2 hours, right? But let's just see. So first we got graph transformations, right, which is pretty easy. And yeah, so it says figure three shows a sketch of part of the curve of equation y equals f of x. The curve crosses the y-axis at the point 0, 8. The line with equation y equals 10 is the only asymptote to the curve. The curve has a single turning point, a minimum point at 2, 5, as shown in figure 3. State the coordinates of the turning point of the curve with equation y equals f of a quarter x. Now this one, again, it's graph transformation, guys. Before I go through it, remember, these are your graph transformations right here. I want you guys to tell me on a scale of 0 to 10, 0 being I have no clue about these, and 10 being I've got these down. 100%, I know these how these work. I can memorize these. How do we find these? They can't see the question? No? Oh, oh my days. I'm so sorry. I'm so sorry. Oh my days. I have to do this and then I do that. Do you see? No, but you see the okay, okay, okay. Alright, cool, cool, cool. He's cooked. Okay, okay, okay. Alright, cool, 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 cool. Okay, you guys can see it now. You guys can see it now. Alright. Apologies, apologies, apologies. Alright. See screen big come on. Alright, cool. So you guys can see it now. My bad, my bad, my bad. This is not a good start. It's not a good start. Okay, it's not a good start, not a good start. All right. Cool. So let's look at this question, right? So it says figure three shows a sketch of the part of the curve of equation y equals f of x. The curve crosses the y-axis at the point 0, 8. The line with equation y equals 10 is the only asymptote. Curve has a single point, a minimum point at 2, 5, as shown in figure 3. State the coordinates of the minimum point of the curve of equation y equals f of a quarter x. So again, graph transformations, right? How do we find this? Can you go over the order? Yeah, sure. I'll do a couple questions on that. But yeah, with this one, with these types of questions, you have to know this. These are your rules here, right? So make sure that you know these off by heart. Yeah? I'm just looking at the chat. Okay, cool, 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 cool. All right, so let's do this. Let's do this. Yeah, I was looking. Sorry, guys. Sorry, guys. All right. Anyways, um, so firstly, state the coordinates to the minimum turning point of the curve of equation f of a quarter x. Right now, remember, if we know our graph transformation, what I like to do when I'm doing a minimum point, right, or a graph transformation question, is for example, the minimum point is 2, 5. So I'm gonna put this here. I'm gonna put f of x here, and then I know that this is the point 2, 5. Right, that's the minimum point. Now, if I want f of a quarter x like that, then what does that mean? Remember, this is going to be a horizontal compression with a scale factor of 1 over a, right? Remember, f of ax means that you times the x coordinate by 1 over a, right? So in our case, our A is a quarter. So if I want to figure out the coordinates of that, I'm going to times the x coordinate by 2. It'll be 2 times 1 over a quarter. Our A is a quarter here. So we get that there, and that's 5. So therefore, that's just times them by 4. That's going to be 8, 5. And that is part A. Does that make sense, guys? Yeah, thank you very much, Faye. Yeah, good stuff. Adil, yeah. Yep, brilliant. 8, 5. And then now Part B says state the equation of the asymptote of the curve of equation y equals f of x minus 3. Now remember, let me get this here. Get this graph here. So this is the graph of f of x, right? Now f of x minus 3 is just going to shift it down vertically by 3 units. So I'm going to draw it here. So essentially it's going to look like this. It's going to look like that. No, if I move it down by 3 units. So everything's going to go down. That's going to be 0, 5. That's going to be 2, 2. And then the asymptote, remember, if the asymptote was at y equals 10, it's going to go down to 7, no? So that's going to be like that there. That's going to be y is equal to 7. So that is going to be the answer for part B. Does that make sense? Yeah, good stuff. Good stuff. All right, cool. So this is good. This is good. This is good. All right. So that's done. And then part C, right? Says the curve of equation y equals f of x meets the line with equation y equals k, where k is a constant at 2 distinct points. State the set of possible values for k. So again, let me get this graph. We get this graph. This is the curve here, and apparently there's a line y equals k. Now remember, y equals k is a horizontal line, no? So all we're gonna say here is that, well, fine. If I've got y equals k, which I know is a horizontal line, like that there, then if it intersects twice, well, what would the minimum value be? Well, there's going to be one there. It's essentially going to be between these two, no? So k at the very lowest, remember, intersects twice. Right now, it's intersecting once at the minimum point. So this is k equals 5, like that. And then obviously we've got this asymptote, which intersects once. So for it to intersect twice, it needs to be between y equals 10 and essentially y equals 5, but this is k, isn't it? So it's between these two values here. So what we can say then is that therefore this is just going to be between, k is going to be between 5, right, and 10. Make sense? Yeah, good stuff. Is anyone else failing at me? I saw every comment I see on the video videos, everyone's aiming for A star. Now you're doing fine, this off. Don't worry, man. Don't worry, you're doing good. Don't worry. And good stuff, Nicole, Albie, brilliant. Dan, you're the MC. Oh, okay, I thought you said something about my mic. All right, cool. Cool. So we've done that. And then part D says sketch the curve of equation y equals f of x. Let me zoom in a bit. Sketch the curve of equation y equals minus f of x, right? Showing clearly the coordinates of the turning point. So let's get this here. Let me put this here like that. And then let me paste this here. This is the part D. And then this is our curve, right? What I always do is just always have the sketch that they've given you and just use it. So if I want minus f of x, remember what minus f of x does? Minus f of x, right? Is just a reflection in the x-axis. So if I want to reflect this in the x-axis, well, what would that look like? Well, it's going to look like this, no? It's going to go like this, like that. It's going to be like that, essentially. It's going to be like that, basically. And then what will happen is, well, everything is going to flip. Remember, if it's a reflection of x-axis, the y coordinates get multiplied by -1. Yeah. So in this case, we can see quite clearly that that's going to be 2 minus 5. And then if I was to just draw a line just to make it like that, and then that's going to be 0 minus 8. Like that. And then the asymptote, this is quite a bad drawing, sorry guys, is going to be at y equals -10. And that's it. Does that make sense? Yeah, this is Edexcel. This is Edexcel. Yeah. Is it not? Let me just check that. Hold on. Let me just check that. What is it? Graph transformations. No, it's not. I'm just looking at your message. Where who said that? Let me just see. I just saw something. Sonic from Sonic. Is it not 5 is less than or equal to K? No, it's not, because remember, it says that it has to intersect twice, right? It intersects at 2 distinct points. When it's equal to k, right, you're at the turning point. That's only one point of intersection. So I hope that makes sense. It's in between 5 and 10, non-inclusive. Yeah. All right. So we've done that one. Let's go to the next one now, which is connected rates of change. So we've got this one here. Guys, what do we think about connected rates of change? Looking at this one, put a 0 if you think I have no clue, I'm cooked, or put a 10 if this is light work. If this comes up tomorrow, I'm chilling. What do we think? Think fine as well. Cool. Cool. Let me see. Five, tens, twos, tens. All right. Okay. Nah, you're not cooked, Harry. You're good. You're good. All right, let's have a go. Let's have a go. So, firstly, it says a container. I need to lock this phone because this phone's distracting me. Anyways, it says a container is made in the shape of a hollow inverted right circular cone, right? The height of the container is 24 centimeters and the radius is 16 centimeters, as shown in the diagram above. Water is flowed into the container. When the height of the water is h centimeters, the surface of the water has radius r centimeters and the volume of the water is v centimeters cubed. Let me zoom in a bit actually so you can see the question better. Hold on. So show that v is equal to 4 pi h cubed over 27. And they've told us the volume of a right circular cone with vertical height is v equals a third pi r squared h. So we know we're using that formula, right? It's only 2 marks. So what I'm going to do, let me just put this here. So basically, this is our part A. And then we'll put this here like that. And obviously, we're trying to figure out what the volume is, right? And we know that v is equal to 1 over 3 pi r squared h, like that. Now, because this is what we're trying to show, if I look at my show that, remember when you're doing these types of questions, guys, always look at your show that. Bugsy, come on. Anyways, whenever you're looking at a show that, always see what you've got in front of you. The show that has only h's in it in terms of a variable. The volume formula has r and h. So what that tells me is that I need to express r in terms of h and hopefully get something all in terms of h and get that form. Now, whenever you're doing this, if you see this come up tomorrow, right, when you see a cone, what you want to do is just remember, if you have a cone like the big cone and then any small cone, they're always going to be mathematically similar, right? That's just something to just memorize. They're always going to be mathematically similar. And what that means, what I'll do actually, let me just draw 2 cones so it's clear. So let me draw a cone like this. So this is the smaller cone, and then I'm going to just connect them at the bottom like that, and then do another one like that. Okay. Now this one has a height of h and it has a radius of r, like that. And what I'm going to do, I'm going to just copy that and then make it big. So this now, if I make this big, this is going to represent my bigger cone, right? And I already know the dimensions for that. That's 24 and 16. So I'm going to rub that out. We'll put 24 and 16. Let me just check the chat just to make sure that you guys can see the question and I'm not cooked. Okay. Cool. So now we know that this is 16. Put this here. That's 16. And this is 24. The height is 24, right? Height is 24. Okay. Because these are mathematically similar, it means that there's a scale factor that takes me from this to that one, right? And we've got 2 lengths. We've got the radii for both. We've got the heights for both. So what we can do is find expressions for the scale factor for the radii and the height respectively, and then equate them. So what we can say is that, for example, the scale factor between the radii is going to be the larger radii, 16, divided by the smaller one, right? 16 over r. And as well as that, the scale factor for the heights is going to be 24, the larger one, divided by h. And because we're dealing with a mathematically similar object and they're both lengths, the scale factors have to be the same. So what we can say then is that, well, 16 over r, it has to equal 24 over h. And then now we can use this equation to get an expression for r in terms of h that we can put back into our formula. So all we need to do now is just cross multiply. So it's going to be 16h is equal to 24r. And then that would mean that r, let me just do it here. That would mean that r is going to equal 16h over 24, no? And then simplifying that, what goes into that? 8 would be 2h over 3, right? So we've got an expression for r in terms of h, right? R is equal to 2h over 3. And then we can use it to put into the formula. So hopefully when we do that, we can it will give us the show that we want. So I'm going to put this here. And I know that r is equal to that. So if I put that in there now, then that would mean that I'm going to get v is equal to 1 over 3 pi, and then it's going to be 2h over 3 h, or squared, sorry, and then h here. And that would mean that I'm going to have 1/3 pi, and then it's going to be, well, that would be 4h squared I'll write times here, 4h squared over 9, and then h. And then tidying all of that up, that's going to be v is equal to, and then the numerator is going to be 4 pi h cubed, because I've got h squared of h, divided by 27. And that's exactly what they wanted. Let me just put that there. Yeah, brilliant. Show that we get that there. So we've done that for 2 marks. Does that make sense, guys? We're happy with that? Yeah, I'm just going to make sure all good. Yeah, okay. Just looking at the chat. Afan. Oh. You guys are funny, man. All right, cool, cool. So we've done that. Part B. Let's have a read of it. Let's have a read of it. It says, how many marks is this, by the way? Hold on, let me move this. What does that say? It's 5 marks. Let me just grab that then. That's 5 marks. So it says, water flows into the container at a rate of 8 centimeters cubed per second. Find in terms of pi the rate of change of h when h is equal to 12. What do we think about something like this, guys? Put a 0 if you think I have no clue. I'm cooked here. This is 5 marks gone for me. Or put a 10 if this is light work. Daniel, this is too easy. I didn't come for these easy questions. What do we think? Okay. Yeah, AH, exactly, exactly. The stream is going to be about 2 hours. So it's going to be, I think, just before 9, I'll finish. Okay, you pretend to be in my exam tomorrow. No, you're not cooked, Bugsy. You're good. This is a warm up. All right, cool. All right, cool. No problem. So let's do this. All right, it says water flows to the tank. So we need to find the rate of change of H. Now, remember, when you're dealing with these types of questions, guys, right? If you ever see rate of change, right? If you ever see that word rate or rate of change, this is just dy over dx. It's a derivative, right? Now, to contextualize it, it's the rate of h. It's the rate of change of h that we're looking for. So what that means is that we're looking for dh by dt. That's what we're looking for. Now, whenever you see these types of questions, when you're looking for a derivative, it's a chain rule problem, right? You're finding a connection of you're finding a chain of derivatives to connect, right? So what I always do is this. Remember the chain rule, guys, that you learn at the beginning of year 13 or whenever you learn it, right? Dy dx is going to equal dy over something multiplied by that same something dx, right? What is the connecting variable? Obviously, we use du, don't we? Yeah. So in this case, we need to figure out what that connecting variable is. So if I do this here, it's going to be dh over something multiplied by that same something dt. Yeah. And as you can see, the question marks will cancel and that will leave me with dh by dt. So we need to figure out what that connecting variable is. And with these types of questions, let me just see. You guys are funny. And yeah, that's correct. That's correct, Jeremiah. But yeah, with these types of questions, it's always the same, right? We're dealing with a cone or a cylinder. It's volume, right? So, and also as well, if you're not sure, always look at the units of measurement, by the way. They've told you as well as that water flows into the tank at a rate of 8 centimeters cubed per second. Look at the units of measurement. This is a cubic measurement. That's a volume, right? Per second. That's time. Remember, that's centimeters cubed over s. Remember, s to the minus 1 over s. This is going to be dv by dt. No? So that way, we could say that if you've got that, that means it's going to be a connecting variable. And obviously, it's 8, isn't it? So I'm going to put that there. So I'm going to put dv there and then put dv there like that. And then we know the water flows into a container at a rate of 8 centimeters cubed per second. That just means that dv dt is equal to 8. Does that make sense, guys? We're happy with that? Yeah. Now, differential equations did come up, but not a connected rate of change problem such as this. Yeah. But they're all similar. They're all under the same umbrella. But this specific type of question didn't come up. Yeah. All right. So now we need to just figure out what dh by dv is and dv by dt. To be fair, we know what dv by dt is. It's 8, no? So it's going to be dh by dt is going to equal dh dv over dv multiplied by 8 because we know what that is. Now, what that means is that I need to figure out what the h by dv is, or in other words, I need to find a formula that connects the variables h and v. And we did it in part A. Remember, the formula for the volume was 4 pi h cubed over 27. That's v in terms of h. So what I can do is write that there. I know that v is equal to 4 pi h cubed over 27, right? Let me just, yep, that's fine. And then remember, this is v in terms of h. So I can differentiate that to get dv by dh, no? So if I do this, it's going to be dv by dh. And remember, also, what I'll do actually, just to be super clear, right? Remember, when you do these type of questions, right? The only variable in this case is that letter H here. That's the only variable here. So all we need to do is let's get rid of, or let's not get rid of it. I mean, let's just separate the constant part. So we can rewrite this as V is equal to 4 pi over 27 H cubed. And then now we can differentiate that. You could have differentiated them, but it's just, I just want to be super, super clear. Yeah. So it's going to be dv by dh. Now, how do I differentiate that? Remember, this is a constant, so I'm going to write 4 pi over 27. And then I'm going to multiply by the derivative of h cubed, which is 3h squared, like that. And then now, all that means is that we've got dv by dh is going to equal that 4 pi, that's 3 over 27. How many times does that go into? Is that 9, no? Be 4 pi over 9 h squared. Does that make sense? Let me just double check that because this is live and I'm not making no silly mistakes. 4 pi over 27 times by 3. Yeah, perfect. All right, so this is dv by dh. Now remember, we need dh by dv because we need to get that chain. So we're just going to take the reciprocal. What you can do now is, what I'll do, I'm going to rewrite it again. dv by dh is going to equal 4 pi h squared over 9. And then if I take the reciprocal of that, I'll get dh by dv. h by dv. And this is going to equal 9 over 4 pi h squared. That. Now I've got an expression for dh by dv. So let's get what we had before. Remember, we're looking for the rate of change of the height. We need dh by dt. So I'm going to get this here. And I know what dh by dv is now. So I'm going to put this here. I'm going to say then that we're going to have dh by dt is going to equal dh by dv, which I know is 9 over 4 pi h squared times by 8. And then now remember, it said the rate of change of the height when h equals 12. So all that's left to do is just plug in 12 and then you're done. All right. So we're going to plug in 12 and see what we get. So we're going to have dh by dt is going to equal 9 over 4 pi. And then it's going to be when h equals 12. I brought h equals 12 here. It's going to be 12 squared like that times by 8. And if I put it into my calculator, see what we get. It's going to be 9 over 4 pi, and then 12 squared times by 8. Okay, that doesn't give me a exact value. So what I'm gonna do is I'm just gonna calculate this part then. If that ever happens, I'm just gonna calculate everything without the pi, right? And that should give it to me then. So if I do that, if I'm gonna delete the pi, just work out that constant part, that gives me 1 over 8. So therefore, that in yellow is 1 over 8, like that. That's 1 over 8. And then that pi is there on the bottom. No? So therefore, the answer is going to be 1 over 8 pi. And that's the answer. Does that make sense, guys? You happy with that? Are you getting in the ring with Bison Maths anytime soon? Nah, he's the GOAT. No chance of that. Nah, he's the GOAT. He's the GOAT. But yeah. All good? My calculator was in radians. Yeah, but we wasn't calculating any angles, so it was okay. Yeah? I'll give you a 5 if you can't do my test. No, you got this. You got this. You got this. All right, cool. So this is done. Perfect. Now let's go to the next question, which is what I've got for you: exponential modeling. What do we think about these types of questions, guys? Put a 0 if you think this is absolutely catastrophic. Hate these types of questions. This type of question specifically comes up a lot, to be fair. I even remember when I was doing A levels, these types of questions, especially the part D, comes up a lot. But yeah, put a 0 if you think I have no clue, or put a 10 if this is again light work. Okay. If I've got time, I'll go over part A again. I just want to make sure I get through everything. But remember, as well as that, you could always just watch this back when it's done. Yeah? As that the name of the maths world. That's big praise. That's heavy praise. I appreciate it. All right, cool. So let's do this now. All right. So it says a scientist is studying a population of lizards on an island. The number of lizards n in the population t years after the start of the study is modeled by the equation n is equal to 1,800 plus divided by 2 plus 3 e to the minus 0.2 t. And use your model to answers part A, B, C, and D. Find the number of lizards in the population at the start of the study. So remember, this is very easy. Part A, at the start, initially, if you see those words at the start, initially, that just means when t is equal to 0, right? So I'm going to put this here. At the start, is t is equal to 0, like that. So I'm going to say t is equal to 0. What happens? Well, we're going to have 1,800 divided by 2 plus 3e to the 0. And that's going to be 1,800 plus 2 plus 3 is going to be 5. What's that? 1,800 over 10 is 180. That's 360, no? But let me just check because this is a live stream and I'm not embarrassing myself with simple math. So 1,800 over 5 is 360. 360. Did I say 300? I meant 360. If I said 300, I definitely meant 360. But anyways, cool. Cool. Thank you very much, Joel. 0 wins. Yeah, exactly. The live stream will end at approximately 9 p.m. 9 p.m. I think. But yeah. All right. So Part B says the model predicts an upper limit to the number of lizards on the island. State the value of this limit. Again, with these types of questions, right? You're looking to see what happens as t gets really large, and you can do this a number of ways. If any of you guys did join the live stream for the functions, you could just, for example, I'm gonna write this here. I've got 2 plus 3e to the minus 0.2t, right? Now, as t, sorry, gets really large, I'm going to rewrite this here. So I've got 1,800 over 2 plus, and I'm going to rewrite that as a fraction. It's going to be 3 over e to the 0.2t. Now, as t gets really large, remember, this is an exponential expression here. It doesn't matter that there's a 0.2 there. As t gets really large, that's going to get super big. Yeah. So what will happen, essentially, let me just see the chat. Yeah. What will happen is that it's going to be 1,800. Or let me do it like this actually, so it's just super clear, right? Yeah, like that. So, but there, as t tends to infinity, right? You're basically going to get 1,800 over 2 plus 3 over something really big. 3 over something really big. Now, if the denominator is really big, right, what happens? You're going to get practically 0, no? So it's going to tend to 0, that part. So it's going to be 1,800 over 2 plus 0, essentially. That's just 900. So therefore, it's going to be 900. Does that make sense? Just check the chat, just see that we're all good. Just sure. Yeah. All right. Yeah. Ahmad, good stuff. Good stuff. You sent me an email with a question, Ahmad. I think that's you. Appreciate that. But yeah, cool. So we've done that. And then now, that's part B. So part C says, let me just put this here. What I'll do actually, let me just put this here. Okay. Don't worry, we'll get to some hard questions. Don't worry. Don't worry. We're gonna get to some hard questions. All right. So part C, let's read it. It says, let me just, what does it say? Find the value of t when n is equal to 780. So like that there. So putting this in here. Okay. Oh, I appreciate that. You sent me £1, Jack. I've never seen that before, but I appreciate that. Thank you very much. Thank you so much. Anyways, yeah, we need to find t when n is 780, right? So remember the actual function. What was it? It was that there. So it's there. And then yeah. So I need to find t when n is 780. So it's just rearranging, isn't it? So I'm gonna just say, well, I've got 7/80 for n is gonna equal 1,800 over 2 plus 3e to the minus 0.2t. And then now I need to solve for t. So I'm gonna say, well, if I times up, it's gonna be like that there, like that, and then it's gonna be equal to 1,800 over 780, like that. Just flipping them over. And then now, what is that going to be? Let me put it in my calculator just to simplify that. 1,800 over 780. That's going to be 30 over 13. So it's going to be 2 plus 3 e to the minus 0.2t is equal to 30 over 13. And then what I want to do is I want to isolate the e. So to do that, I'm just going to say, well, e to the minus 0.2t, that's going to equal, I'm going to do 30 over 13. I'm going to take that 2 away, and I'm going to divide by 3 now to give me that. And I'll put this into my calculator and see what I get. It'll give me what I'll do is I'll do that there. 30 over 13 minus 2 over 3. And that gives me 4 over 39. So I get e to the minus 0.2t is equal to 4 over 39. And then now remember, you're trying to get t. We've got e there. We're just gonna take the ln. Yeah. I appreciate you guys. I appreciate you guys. I'm seeing Matthew San. Thank you very much for the £2. Yo, Dan is making money. Come on, man. I appreciate it. So therefore, we're gonna say minus 0.2t is gonna equal the ln of 4 over 39, right? And that just means that t is gonna equal ln of 4 over 39 divided by minus 0.2 divided by minus 0.2, and that will give me I'll do this here. Ln of 4 over 39, and that will give me divided by minus 0.2, and that gives me 11.38. T is equal to 11.38, blah, blah, blah. And what accuracy did they want it on? Want it to one decimal place, so it's going to be 11.4. So T is going to be 11.4. And that's it. Did we get that? Yeah, Dylan got that. Well done. I appreciate you guys. Abdul, Isoloff, thank you so much, man. I appreciate it. Robert Burton, I'm just scrolling up. I appreciate that as well. Thank you. I really appreciate it. Thanks a lot, man. But yeah, all good? Okay. Okay, so you've done that. So t equals 11.4. So that one's done. And then part D. Now this one is a bit tricky, right? I see it come up a lot. What do we think about part D, this type of questionnaire? Put a 0 if I'm cooked. I've been saying I'm cooked a lot. As soon as I started making TikToks, I've never heard that word used so many times in my life. So I'm gonna keep using it. But yeah, what do you guys think about this one? Put 0 if I'm cooked, or put 10 if this is light work again. Don't forget to put the ln as the numerator. Did I do something wrong? MMZ. Did I do something wrong? Thank you very much, Pumu Penguin, as well. Right? Let me just check because I just saw a message. Let me just check I got that correct, by the way. 11.4? Yeah, yeah, no, I got that fine. I hope that's okay. Let me go back to there. Yeah. Okay. Thanks a lot, guys. Yay, the goat. I appreciate it, man. Suit Craj. I hope I Hyundai at £1. I appreciate it. Thank you so much. Thank you so much, guys, man. I really appreciate it. But yeah, doing this one, we need to show that the rate of growth dn by dt is given by that there, right? Okay. Now obviously we need n. So let's get n again. That's n right there. So let me screenshot this and bring this here. Okay. So if I've got n, right, and I need dn by dt, that just means I need to differentiate. Remember again, the rate of growth. When you see that word rate, it means to differentiate. So all we're doing is just differentiating, right? So firstly, we've got n there. Now, if I want to differentiate that, you may be tempted to use the quotient rule, sorry, and you could do so. However, if you look at the numerator is not a function of t, it's just a constant. So what you could do is just manipulate algebraically and use the chain rule, right? So bring up that denominator. So I'm going to rewrite this as n is equal to 1,800, and then it's going to be 2 plus 3e to the minus 0.2 t all to the minus 1, right? That's what n is. And then now, if I want dn by dt, which is what they want the rate of growth, I just differentiate this now using the chain rule. So doing that, it's going to be dn by dt is going to equal, and then what happens here, the minus is going to drop to the front, so it's going to be minus 1,800, like that. And then it's going to be 2 plus 3e to the minus 0.2 t. And then remember, I'm going to take 1 away from that power to be minus 2. And then after that, remember, this is a chain rule problem. I need to multiply by the inside differential of this function here. So I need to differentiate that. Now, how do I differentiate that? There's 2 terms in it. The 2 will go to 0, right? So that's done. And then I need to differentiate this 3e to the minus 0.2t. Now there's a constant here, so I'm going to put a 3, and I'm going to times it by the derivative of e to the minus 0.2t. Now remember, if you have let me do it here. If you want to differentiate, for example, actually, I don't know where my picture is. Let me do it right here. If I want to differentiate dx of e to the f of x, right? Like that, then this is just equal to, you differentiate the power f dash of x, e to the f of x. That is just something you just need to know, right? So if I want to differentiate e to the minus 0.2t, I need to firstly differentiate the power. Minus 0.2t differentiates to minus 0.2. So minus 0.2 will go there. And then you're just going to have the same thing, e to the power of minus 0.2t. Like that. And then now what we can do is tell you, Saku, where do you get these questions from? These are from the Edexcel International A Level papers. They're all on the Edexcel website. I always recommend my students to use them. Yeah? Would quotient rule work too, Dan? Millie, it would work. It would work. You could definitely use the quotient rule. But obviously, it's just more efficient if you use the chain rule. Yeah. But yeah. So now this is my dm by dt, and obviously I need to tidy this up. So I'm going to move this here. Let me move this here, and then obviously what I'm going to do now is I'm going to get all of the constants. You want to tidy this up here. So I'm gonna multiply all of these and see what I get. So if I do that, I'm gonna get let me do it there. It's gonna be minus 1,800 minus 1,800 times by 3 times, whoops, 3 times by minus 0.2. Let me just see. Yeah, that's fine. That's fine. And that gives me 1,080. So therefore I can say dm by dt is equal to 1,080, and then it's going to be 2. What have I got? I've got a couple things, to be fair. I've got that 2 plus 3 e to the minus 0.2t to the minus 2, and I'm going to multiply that by e to the minus 0.2t. Now remember, this is our answer. This is dm by dt. However, let's get the show that up, by the way. The show that is this right there. We can see that dm by dt is in terms of n, not t, right? So what do we do in this case? Well, what you want to do is remember your actual formula, the function given to you. You can rearrange this to get expressions for anything you like. Remember, it's an equation, so you can do that. If you see any variable in a derivative, you can use it. So what I'm going to do, let me bring this down here. And so remember, we want everything in terms of n, and at the moment it's in terms of t's. So what we're going to do is straight away, this is really good because I've got this right here. This is 2 plus 3e to the minus 0.2t. Now, when I look at this, I can rearrange to get that. If I do that, that's just going to be 2 plus 3e to the minus 0.2t is going to equal 1,800 over n. And that gets rid of a lot. That's very, very helpful. So what I can say so far is that dm by dt then is going to equal 1,080, and then I'm multiplying by e to the minus 0.2t. So I'm here so far. Does that make sense, guys? We happy with that? I'm just checking. Okay. And Raza, I just seen your £1.99. I really appreciate it. Thank you so much. Yeah? Okay. See, I'm frozen. I'm frozen. No way. Am I frozen? Hold on. I'm seeing I'm frozen in the chat. Am I? Oh my days, I'm frozen. Why am I frozen? Hold on. No, I'm not. Am I frozen? We back? Okay. You're good now. All right, cool. Cool, 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 cool. All right, cool. I'm back. I'm back. I'm back. Thank you. All right, cool. So now, yeah, we are here and we need to get everything in terms of n, don't we? So remember, what we need to do now is look at that e to the minus 0.2t. We need to rearrange that, right? And again, we're going to use this because remember, we've just figured out that there. Let me copy this. Oh, I need to lower this because I was just checking to see if I frozen. All right. Anyways, so we want to get e to the minus 0.2t on its own. So what I'm going to do is let me just get rid of the highlighter because it's a bit distracting. It's not letting me get the highlighter. Okay, cool. So now, if I want to get that, then I can say, well, that's going to be e to the minus 0.2t is going to equal 1,800 over n minus 2 divided by 3, isn't it? And then now what I would do just before I actually start tidying things up, right, is I'm going to just make this a bit simpler to work with. So if I work with that, then what can happen is that I'm going to have 1,800 over n, like that. I want a common denominator, right? I'm going to write this as minus 2. I write over 1 here, and it's going to be 2n over n, isn't it? Like that. Over 3. And then that means that I'm going to have 1,800 minus 2n over n. And then this is all over 3, like that. And then what you could do is, remember, this is your numerator, isn't it? This is your numerator right here. Let me just check I'm still not frozen. Okay, cool. I'm still not frozen, so got that there and got that there. Now, remember, this is the numerator at the top. I can write like this, 1,800, let me do that, 1,800 minus 2n over n, right? And then I can multiply that by the denominator, which I can write as 1 over 3. And that means I've got 1,800 minus 2n all over 3n, right? And that is our expression for e to the minus 0.2t. So I'm going to write this here, and then I'm going to get to show that again. So where are we? We are right here. I'm going to copy this. This is where we're at so far. Going to copy this here, and we're going to say that we've got the NDT right here, and now we can substitute that in. So I'm going to do that. So it's going to be 1080, and it's going to be 1800 over n to the minus 2. And we're going to multiply by that expression there, which is going to be 1800 minus 2n over 3n. Right? And now the NDT is all in terms of n. So this is really good progress. Obviously, it's not to show that we're still trying to get there, but it's good progress because now we've eliminated the variable t and got it all in terms of n. So this is definitely on the right track. Now it's just about algebra and tidying up and being very, very careful. So what do I do? Well, firstly, what can I do here? What can I do? I'm gonna work this out. Remember, this is 1080, right? That there is the same as that minus means that I can flip it. So it becomes n over 1800 all squared, right? These two are exactly the same. So I'll just write this just to be super clear. Like that. 2n over 3n. And then now I've got a fraction and I'm squaring it, right? Let me just see. I'm just looking. Why is everybody putting one in the chat? I'm not frozen on mine. What does that mean? Type one if that is the goal. Oh, I appreciate it. I appreciate it. You guys are too funny. I appreciate it. You guys are the best, man. Thank you so much. All right. So now I'm gonna square that. So it goes 1080 times by n squared. And by the way, that person actually sent me £2, I think. Let me just see. Noel, thank you so much. I didn't even realize. Apologies. Thank you for the £2. Thank you so much. I appreciate it. Let's see if we can get to £100. No, I'm joking. I'm joking. That was a joke. That was a joke. That was a joke. That was a joke. Anyways, 1080 n squared over 1800 like that times by 1800 minus 2n over 3n. This is where we're at. So now, let me just see. Okay, I'm gonna go back. I'm just gonna make sure I'm gonna get everything because I'm gonna make sure I get through the hard questions, but I'm definitely gonna go back. But yeah, so now we can tidy things up. So I've got here, firstly, I've got 1080 over 1800. Let's work out what that is. 1080 over 1800 squared, by the way, is going to be 1 over 3000. So I'm going to have 1 over 3000, 1 over 3000, like that, n squared. And then I've also got these here. To be fair, though, I can actually cancel an n here, no? Let me do it again, just so it's clear. So I got it there, like that. And then what I can cancel is 1 n there, no? I can cancel that n, that will be 1, and then I can cancel one of them there. And Maya, thank you very much. Thank you very much for the £2. I appreciate it. All right. So now what that means is that, well, fine, I've got 1 over 3000, 1 over 3000, and then I've got n, and then I've got times by 1800 minus 2n over 3. Now let's get the show that again, because remember, when you're doing a show that question, always have in mind what it is you need to get to, what you need to show. So I'm going to put this here. This is what we need to get to. This is where we're at. This is the n by dt, by the way. I need to write the n by dt. The n by dt. So what can I do now? All right. Now, what have they got? They've got a constant here. So what I'm going to do, I'm going to bring this all together. So this is going to be n bracket 1800 minus 2n, right? If I bring the numerators together over 9000, no? Like that. And then now, if I look at the show that, they've got a factor of n on the outside, which is what we have. But in the inside, they haven't got a 2n. They've got an n there. That tells me that I need to take out that 2. And we can see quite clearly we're actually done, aren't we? Because if I take out that 2, it's going to be n multiplied by 2 bracket 900 minus n over 9000. Oops. 9000. Like that. And then what happens here? Well, goodbye. That's going to be 4500. So therefore, therefore, the n by dt is going to equal n bracket 900 minus n over 4500. And the constant a, we can see quite clearly, a must be equal to 4500. Does that make sense? Jamil, I appreciate it. You guys are the best, man. No, you guys are, I should do a live every day. You guys are funny. Now, thank you so very much, man. I appreciate it. Okay, hold on. New maths question. If maths then makes 2 long videos at a rate of a week, how much should you guys are funny. All right, cool. So that's fine. I think that's okay. Let me just all right. So that's a equals 4500. We happy with that? Yeah. All right. So that's done. And part double I, right? It says hence state the maximum value, or hence state the value of n at which the rate of growth is a maximum. So this one, actually, somebody sent me a DM about a question that is very, very similar to this. Hold on. Whoops, what's happening here? Let me screenshot it again. Let me grab that, copy, and then put this here. Paste. Yeah, okay, brilliant. All right. So this is the questionnaire. Hence state the value of n at which the rate of growth is a maximum. Now, remember, some of you may be thinking you see maximum, you differentiate, make equal to 0, right? But be careful. It says when the rate of growth is a maximum. Your rate of growth is dm by dt. So there's no need to differentiate if that's what you were thinking, right? You need to look at where this is at its max. You need this to be the maximum. So all you're going to do is look at your graph and ask yourself, or look at your expression for dn by dt and ask yourself when n is at a max, when the entity is at a max. Everybody's put a 1 again. Why is that? Let's see. Where's my thing? Mate, I appreciate it. NS Dillion. NS Dillion. Thank you very much. Yeah? Cool, cool, cool. Thank you very much. All right. So now we need to figure out where dn by dt is at its max. Now remember, dn by dt was equal to that function there, no? So I'm going to say dn by dt is going to equal n 900 minus n over 4,500. Now, what type of expression is this? What type of equation is this? What type of function is this? It's a quadratic, no? Because we've got n and something inside with an n. If we expand that, it's going to be a quadratic equation. So how do we find out the rate of growth of a maximum? Or how do we find the max or the min of a quadratic? It's the turning point, right? So what you could do is say, well, fine, what I would do is I'm going to write this out like this. I'm going to write dn by dt. And then that 4,500 on the bottom, I could try like that. And then I'm going to write n and then 900 minus n. And just for context, if I expand that, it's going to be, it will be what? 900n minus n squared, no? If I just expand that bracket part, and we can see, well, this is going to go like that. No, it's going to be an upside down parabola. Yeah. So if I want to sketch this, right? Let me get an axis going. Where's the axis like that? All right. So I'm going to call the vertical axis dm by dt, aren't I? Yeah. I'm going to call this dm by dt. This is going to be dm by dt. This is, and this is going to be n. And well, this is quadratic. We know that, for example, the roots, by the way, is going to be when it's 0, right? So if this is equal to 0, what will happen? N is going to equal 0 there. So I'm going to put 0 there. And then, well, this one is going to be 900 minus n is equal to 0. And that means that n is equal to 900. So the two roots of this quadratic are going to be 0 and 900. And we know that it's upside down. So it's going to go like that. Like that, right? Where is this at its max? Where is the turning point of this graph? You can see that it's just going to be at the midpoint of the two roots, right? It's going to be right here. Whoops. It's going to be right here. That's going to be where the maximum is of this function here. And that right there is just going to be 450. So therefore the value of n is just 450. And that is the value of n where the n by dt is at its maximum. Good stuff, AQA, 0 wins. Dylan, good stuff. I think you guys are sending me 499. Tommy, I appreciate it. I appreciate it, bro. Tommy, thank you so much. Thank you so much. Okay, but we all good at that? Is it not a difference of two squares? Is it? To be fair, it is to be fair, because you could write this as or is it? No, it's not actually. Wait, no, it is. It is. Yeah, yeah. Because if you just do that and then square root it, you get that. No, it's not. No, it's not. No, it's not. Because this here, if it was 900 minus n squared, then yeah, that would be fine. But it's a 900n, so it's not. It's not. Not. Hope that makes sense. But yeah. Cool. Cool. All right. So let's go to the next one. Let's go to the next one. I hope that makes sense by the difference of two squares, by the way. If it was, for example, 900 minus n squared, then that would just be 30 minus n and then 30 plus n. Can you see? There's an n there though, so we can't use the difference of two squares. Does that make sense? Yeah? All right. So let's go to the next question, which I've got for you guys. How long has it been? It's been 40 minutes and I've done three questions. That's not bad. So we got this one. trigonometric identities, right? What do we think about this? Dan integrate ln x. I did it in my last live, to be fair. I actually did it at the end. But yeah, what do we think about this? Put a 0 if you think I have no clue, I'm cooked, or put a 10 if this is light work. And Robert, technically, yeah, you could do the second derivative is equal to 0 because that would be where the maximum of the n by dt is. Yeah, you could do that, Robert. Yeah? What do we think of this? Horrible. Yes, trig identities. I need to go over this. You can see threes, tens, zeros. All right. Okay. So let's have a go at this. Let's have a go at this. It says show that the equation 4 cosec squared theta minus cot squared theta equals k, where k is never 4, can be written in the form of sec squared is equal to k minus 1 over k minus 4. Now, remember, when I'm doing trig identities, right? What I always do is say, well, what have I got given to me in terms of identities and what do I need to get to? Now, firstly, because I've got cosec squares and I've got cot squares, there's a Pythagorean identity that I know connects both of them, right? So remember, if you don't remember it, I don't think it's in the formula book. Let me know if somebody, let me know in the chat. Is it in the formula book? I can't remember. But sine squared plus cos squared is equal to 1, right? That's what you should know. And then if I want, for example, cosec squared and cot, the one that connects them, I'm going to have to divide by sine, aren't I? If I divide everything by sine squared, then I'm going to get, that will be 1. Cos squared over sine squared, that's going to be cot squared. And then this is going to be 1 over or should I be, let me be actually very, very clear to be fair, just so it's super clear. It's going to be, that's going to be 1, or you know what, I'll just do it. I'll just do it all, and also it's clear. Sine squared over sine squared like that. And then it's going to be cos squared over sine squared like that. That's going to be 1 over sine squared like that. And then now that's 1. Cos over sine is cot. So cos squared over sine squared is cot squared like that. And then this one is cosec squared. Let me just see the chat. Anybody let me know if it's in the formula book? Can I please? Thank you very much, Joseph. I appreciate it. Thank you very much. Appreciate the £2, man. 1.99. I appreciate it. Okay. Cool. Cool. All right. So let me just see. All right, cool. Not in the formula booklet, A, RT. All right, fair enough. Yeah, so just make sure you memorize these, yeah? Now, because I've got cosec squares and cot squares, it would make sense for me, for example, to maybe rewrite this as cosecs. Rewrite this as 1 plus cot. So that means I'm going to have, I'll write out again. It's going to be 4 cosec squared theta minus cot squared theta. Whoops. Minus cot squared theta is equal to k. And then I know that cosec squared is 1 plus cot squared. So I'm going to write this as 4 bracket and then 1 plus cot squared. Like that. Minus cot squared theta is equal to k. Like that. And then now, what I'm going to do is, remember, we want sec squared is equal to that, by the way. So what I'm going to do now is just expand, to be fair. So I'll get 4 plus 4 cot squared theta minus cot squared theta is equal to k, right? And then now tidying that up, that's going to be 4 plus 3 cot squared theta is equal to k. Right, now this is a show that question. We need to get sec squared, right? So I'm going to get this here. And we've got this here. To be fair, this is a quite a weird question. So for me, when I look at the show that, right? Well, what do I have here? I've got k minus 1 over k minus 4, right? On the show that. If I take a 4 away, I can get that expression for k minus 4. So for me, what that tells me is that maybe I should maybe do that and see what happens, right? So I'm going to do that. That will give me 3 cot squared theta is going to equal k minus 4, right? And then, well, I might as well get cot squared theta, no? I'm going to get cot squared theta, right, is equal to k minus 4 over 3, like that. That's cot squared theta. Now, again, looking at the show that we've got sec squared here. Does this make sense, by the way, guys? Are we happy with that? Let me just see the chat just to make sure we're all good. Let me loud my thing up so I know it's 2k minus. All right, cool. So I know it's all good. But yeah, hope that's okay. I'm just going to see if there's any questions. But yeah, cool. All right. So because, remember, this is our show that, right? This is our show that right here. We need to show this. Now, if I need to show that, right? I've got a sec squared here, and I'm currently there. All right. Now think about all of the identities that you know. For example, cot squared is what I've got. I need to move that out of the way, to be fair. I may do this one after as well. Not now, but if I've got time after, I may do the second one after. But anyways, this one right here, right. I've got cot squared. Now, what do I know about cot squared? Well, cot squared, I know, is the same as 1 over tan squared, right? And well, 1 over tan, right? Or tan squared in itself actually is another Pythagorean identity that connects them together as well. So the fact that I've got 1 over tan squared may be useful, right? I'm going to just write 1 over tan squared here, right? Is equal to k minus 4 over 3. Like that. And then now remember, let's get the identity that we know is derived from it. So sine squared plus cos squared is equal to 1. Like that. And then remember, if you want to get the next Pythagorean identity, we're going to divide by sine squared. Sorry, by cos squared, because I did it already. Dividing by cos squared, like this. So I'm sure you guys know this anyway, but this is for anybody that maybe doesn't remember it. This is how you can derive it tomorrow. All right? Plus cos squared over cos squared, like that, is equal to 1 over cos squared. Now, all of that, that's going to be tan squared, like that. That's going to be 1. That's going to be 1 over c, 1 over cos is sec squared. Right. So I know that tan squared plus 1 is sec squared. And I've got 1 over tan squared here. So if I can get an expression for tan squared, I can use this identity to get sec squared. And maybe I can get to that expression. So these are the things that you need to be thinking about when you're in an exam, especially show that questions. Think about all of your identities. You need to know all of them off by heart. Yeah? So if 1 over tan squared is k minus 4 over 3, then that means if I take the reciprocal of both sides, that means tan squared is going to be 3 over k minus 4. Now that. And then if tan squared is 3 over k minus 4, and I need to get sec squared, well, I can just use this identity right here. Let me get this. I'm going to copy this and bring this here. So remember, this is the identity that we've derived, like that. We know that tan squared is equal to tan squared plus 1 is sec squared, right? So that means, let me just tidy it up a bit. That doesn't look nice at all. So that means then that, well, for example, if I replace that with 3 over k minus 4, which it is, I can do that. That's not a problem. 3 over k minus 4 plus 1, this is equal to sec squared. Now, this is good because we've got sec squared and we've got it in terms of k. We just need to get it into that form. Let's get the form again. It's k minus 1 over k minus 4. So this looks like it's promising. Yeah, we've definitely done it. So now, if I do this here, how do I combine that? Well, that's going to be 1 over 1. The common denominator is going to be k minus 4, not? So it's going to be 3 over k minus 4 plus k minus 4 over k minus 4. And then what I'm going to do, I'm going to put sec squared on the left-hand side. So I move this here, put this here. I'll put sec squared here. Sec squared theta right here, like that. And then now they've got the same denominator. So we get sec squared theta is equal to, that's going to be 3 plus k minus 4 all over k minus 4. And then that means, well, that's going to be k. 3 minus 4 is minus 1. Done it. Brilliant. 5 marks in the bag. So that means that sec squared theta is equal to k minus 1 over k minus 4. Let me just zoom out so you can see all of the steps. And yeah, does that make sense, guys? It was a bit, to be fair. But we're happy with that. Joseph, I appreciate the 199. Thank you so much. But yeah, we all good? Okay, cool. Right. So yeah, that's pretty much it. So what I'll do as well, remember the formulas, guys, as well. These are the formulas here. Additional formula didn't come up for Edexcel, by the way. So make sure you memorize these. You got the double angle ones here as well. And then also remember the way I derived the two Pythagorean ones. Dividing by cos squared and then dividing by sine squared here. Yeah? Cool. To be fair, do you know a fun fact, yeah? This question was actually the question in my real exam. So this question, you can search it up on Google, is from AQA. I did AQA C3 June 2015. This was the last question on my paper. I saw it, hooked. You know, on this paper, this C3, this is like my paper one, right? I got 100 UMS on this paper. Just, I have to say that. I have to say that. I have to say that I cooked on this paper. But yeah, cool. So we've done that. And then now, let's go to. Do I want to do this next? How much time do I have? I've got a lot of time, you know. Shall I do parametric integration next? This is a hard one, to be fair. Yeah, I'll probably do this next. I'll do this next. Yeah. What do we think about this one, by the way? What grade did you get? I got an A star. I got an A star. So I'm old. Yeah, I'm old. I'm old. I'm 28 in August. I'm 28. I'm 27 right now, but I'm nearly 28. So yeah. What do we think about what do we think about parametric inter Oh no, by the way, I'm actually 20 I'm actually 27 because yeah, I actually retook it. Yeah, I'll tell you after. I had a long trust me, I'm gonna motivate you guys. What's happening here? What's wrong with the internet? Hold on. My thing is just let me just make sure I'm still streaming by the way. Okay, I'm still streaming. Okay, my laptop basically just crashed, right? So I thought that maybe I thought my laptop's there. It crashed, so I thought maybe there was something wrong. But anyways, let me just see the chat. What are we saying? Master Chef. Can see so it's all over my screen. Mate, you guys, come on, man. Hold on, I'm just trying to see that it's all good. Okay, all right. So parametric integration is calm. All right, let's have a go at this question. I'm just gonna make sure that it's all working good. Am I here? All right, cool. Let me just loud up. It's okay. You guys are crazy. Anyways, so doing this one, let's have a look, right? So let's look at part A. It says, figure 6 shows a sketch of the curve C with parametric equations. X equals 8 cos cubed theta and y equals 6 sine squared theta, where theta is between 0 and pi over 2, right? Given that the point P lies on C and has parameter theta is equal to pi over 3, find the coordinates of P, right? Yeah, this is Edexcel, by the way. Yeah. Now, how do we find the coordinates of P? Well, this is easy. We know that we're at P, theta is pi over 3, so we're just going to plug that in. That's an easy 2 marks, right? So I'm going to do this here. I'm going to say for part A, we're just going to plug in pi over 3 into both x and y. So for example, x is going to be 8 cos, and then what I'll do is I'm going to write pi over 3 here, and I'm going to write a cubed here because that's how it's going to be in the calculator, isn't it? Right? And then y is going to be 6 bracket, and then it's going to be sine pi over 3 like that, and then it's going to be squared. So I'm going to plug those in and see what I get. So that's going to be am I in radians? Yeah, I am. That's good. Be 8, and it's going to be cosine pi over 3 um all cubed like that, and that gives me 1. So x is 1 at P, and then for sine now I need to just put that in. For y, sorry, 2, I'm going to change that to a 2. I'm going to change this to a sine like that, and I'm going to change that to a 6, aren't I? So is that correct? Yeah, that's fine. That gives me 9 over 2, or 4.5. All right, 4.5. So that's going to mean, that means that therefore the point P is going to be 1, 4.5. Happy with that? Makes sense? Let me just see. I can see Jake. He will see it soon. What did Jake do? Did Jake donate? I'm just looking up. Whoops. My goat Dan words can express how much I love you and your muscles. Thank you, man. I saw it. Jake, thank you so much, man. I appreciate you. Really appreciate the 9.99. Thank you so much, man. Hopefully this live and the TikToks have been helpful for all of you guys. But thank you so much. I really appreciate you guys joining me tonight as well. Yeah. He'll see it soon. Yeah. See, this time I'm on the chat. I've literally look, let me show you. I'm on the chat. I'm seeing it right here. I'm seeing everything. I've got it right next to me. All right. So cool. So let's continue. Let me just move this here. All right. Am I on? Yeah, okay, cool. So now we've done part A, and then part B. Part B, what does part B say? It says the line L is the normal to C at P. Show that the equation of L is y equals x plus 3.5. Let me copy that. What I'll do is I'll put this here, and then let me paste this here. This is what they're asking us for. Let's get everything we need, by the way. Let me just copy that. So we know that we've got this here, and then we need to get this. So, figure 6 shows that we've got the parametric equations, and it asks us for the equation of the normal. How do we find the normal, right? What ends am I from? I'm from South London. I'm from London Bridge. I'm from London Bridge, which is very close. I live in Borough, which is very close to London Bridge. But yeah. Oh, Dan, I donated £5. Thank you very much, Anika. I didn't see it. Anika, thank you very much. I really appreciate it. Thank you so much. All right. So now, who said this is easy? Hannah, this is easy. Okay, cool. Don't worry. Don't worry. I've got something in store for you, Hannah, and everyone else. I think this is easy. Yeah. So now, show that we need to find the equation of L, the normal. Remember, how do you find the normal? It's going to be y minus y1 is equal to, and I always put n if I'm looking for the normal, right? That just tells me I need the normal gradient, right? Like that. So to find the normal, to find the equation of the normal, the equation of the tangent, you need to differentiate. So we need to figure out what dy dx is. So I'm going to say, well, dy dx, remember, this is parametric equations, is always equal to dy over d theta divided by dx over d theta, isn't it? So what I need to do is figure out the derivative of both of those and then put them in here. So x, now when you're doing this, right, I'm gonna write this. I'm gonna write this 8 bracket cos theta all cubed. Because when I do that, to differentiate this now, it's quite easy to see that this is just a chain rule problem. It's gonna be 24 like that, and then cos theta like that. Let me put this in here. This is gonna drop by 1, and then we're gonna times by the inside derivative of that. Cos theta differentiates to minus sign. So I get that there. Let me just see. Chat. N stands for normal, AQA. N stands for normal. Nah, you guys are trolling. Nah. You guys are trolling. You guys are trolling. You guys are trolling. I'm not gonna look at the chat until I do this question because you guys are too funny. Anyways, yeah. So dx theta is gonna be equal to minus 24 sine theta and then cos squared theta. Like that. That's what dx theta is. Now dy theta. Well, y is equal to what? Y is equal to 6 sine squared theta. So I'm going to write this as 6, and I'm going to write sine theta all squared, like that. And then now, to differentiate that dy by d theta, again, it's just another chain rule problem. It's going to be 12 sine theta. It's going to drop by 1 to just be 1 here, like that. And then we're going to times by the derivative, which is going to be sine differentiates the cos, so it's going to be that. So now we've got expressions for dy d theta and dx d theta. So it could be dy over dx is going to equal, dy over d theta, which is going to be 12 sine theta cos theta, like that, over, and then dx d theta is that minus 24 sine theta cos squared theta. That's what dy dx is. And what you can do now is just cancel, right? Just to make life easier for yourself. So for example, that 12 and that minus 24, that's going to be a minus 2 on the bottom. And then sine over sine will cancel. And then it's just going to be, that will cancel with that. That's going to cancel with one of those. That's going to cancel one. So it's going to be 1. It's going to be that. Like that. It's going to be divided. It's going to be 1 over minus 2 cos theta, isn't it? Let me just make sure I made a mistake. Yeah, that's fine. Yeah? Nova, thank you very much. I've just seen your donation. I really appreciate it. All right. So, Dan, where can I get the questions? It's on my Google, it's on my OneDrive. It's in the description of the other YouTube lab I did the other day. But if anybody has it, feel free to put this in the chat. Yeah? But yeah. So now this is dy over dx, right? And I need to figure out the normal. So remember, the normal at P. In part A, we figured out that the point P had theta as pi over 3. So to figure it out, let me just put this here, by the way, just so it's clear to see what's going on here. Put that there. And then this is going to be, I'm going to just plug in pi over 3 into that. So it's going to be minus 1 over 2 cosine of pi over 3. Let's see what I get there. So doing that, that's going to be minus 1 over 2. Oops. Oh, by the way, I put the minus on the outside. It doesn't matter. It's just a minus, just in case anybody was wondering. 1 over 2 cosine of pi over 3. And then, is that correct? There. I get minus 1. Yeah? So therefore, this is the gradient of the tangent, by the way. Right? So I'm going to say tangent grad is equal to minus 1. So the normal gradient is going to be the reciprocal, the negative reciprocal. That's going to be 1, isn't it? So therefore, we've got n to be 1, and the point P, remember, we're looking for the equation of the normal at P. We figured out the coordinates of point P. It was 1 and 4.5. So I'm going to put this here. I'm going to say P is going to be 1 and 4.5, like that. And remember the equation of the normal is that right there. So all I need to do is just plug this in. I remember it's to show that, by the way. So what I'm going to do actually, let me get all of that, to be fair. So I don't need to keep going up and down. Let me zoom in and get that. So that's the normal. We need to show that we get that. So let me get that. And then I'm going to put this in here. So this is what we have. And then we need to get that. So we obviously have this. So I'm going to bring that down there. So all we're going to do is just literally put this in and see what we get. So putting that in is going to be y minus y1. Let me zoom in a bit, to be fair, just so it's a bit, the ink is a bit better. Y minus y1 is going to be 4.5, and then it's going to equal hold on, it's distracting me, to be fair. I'm going to do it right again. Y minus y1 is equal to n x minus x1. I'm just plugging it into there. It's going to be y minus 4.5 is equal to n, which is the gradient is 1, and then x minus 1, like that. And then that's just y minus 4.5 is equal to x minus 1. And then that means that y is equal to x minus 1 plus 4.5, which is just 3.5. So therefore, the answer is y is equal to x plus 3.5. Is that what they got? Why do I feel like they got a minus? Have I made a mistake? Oh, no, I haven't. Perfect. Does that make sense? Yeah, I'll go over stats and mechanics next week. I'll do a live stream for those as well. I can't leave you guys hanging, to be fair. Yeah? Okay. The live ends about 9 o'clock. I'm gonna do it at 9 o'clock. Yeah? Alright. So got that. You guys are funny. Anyways, so we've done that. Let me just check the chat just to make sure it's all okay. Okay. Cool. So this looks all good to me. Alright, this looks good to me. Alright, so now the next one. Hannah, you said this is easy. This is light. I saw you say. So part C. Let's have a read of that. Yeah? The finite region S, shown shaded in figure 6, is bounded by the curve C, the line L, the y-axis, and the x-axis. Show that the area of S is given by 4 plus 144 of the integral of 0 pi over 3 sine theta cos squared theta minus sine theta cos 4 theta d theta for 6 marks. Put a 0 if you think that I have no clue if this comes up tomorrow. I'm cooked. I'll put a 10 if this is absolutely light. I've never seen an easier question. Daniel, I came for hard questions. You're giving me minor stuff. This is annoying. What do we think? Mate, you guys are... Okay. All right. Cool. 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 All right. I can see 3 zeros, 4s, zeros minus 100. Okay. Okay. All right. So it doesn't look, so it's a bit mixed. Some say it's good, some say it's bad. All right. So let's have a look at this right now. I need to get everything that we need, to be fair. So this one, let me I'm gonna grab this. I'm gonna grab this here. And then obviously with parametric equations, guys, and in A level maths in general, always visualize what's going on here. They're asking us for the area, right? That's integration. So I'm gonna get the curve as well. Yeah. So I'm gonna get everything we need here. So we get this here. And that area of S, if I grab that here and put this here, like that. Okay. So if I put this here, all right. So the area of S is integration. What you could do is you could split up that area. No, if I want the area of S, then surely we could say, well, there's a point of intersection there. By the way, that's the point P, which we know is 1 and 4.5, by the way, like that. And then if I do a vertical line like that, then we've actually got two regions that we can calculate. Remember, this is a vertical line. This is perpendicular. This is a trapezium, to be fair. Yeah. So we need to work out the area of that, and we need to add it to the area of this here. Now, be careful. This is a curve, by the way. This is not a hypotenuse, right? Because that's a curve, as you see, it's curving. So we've got two areas that we need to calculate. Now, how do we get those areas? Well, what you could do is just think about integration and what you're actually doing. To find the area under a curve, you integrate definitely. You just have to create a definite integral. So if I get this here, what should I do it? I'm gonna do it. I know I'm gonna move this here. So if I do this here, then we can set the area of S, right? Remember, I can say that the area of S, just by looking at it, that's what we're looking for. Area of S is going to be equal to the integral between this point right here. That's a 1, by the way. That's a 1. integral between 0 and 1 of that curve, of that line, sorry, L. And we figured out that that is equal to x plus 3.5, like that. So that's going to be x plus 3.5 dx, right? That's going to give us the area of that part on the left, right? And then this curve S here, which I'll do like this, it's going to be like that there, like that there. Now, if I look at this, well, I'm integrating between 1 and this point here. That's going to be x2, isn't it? Yeah? So what I'm going to say is that I'm actually integrating between 1, right? And then I'm going to call this upper limit x2. And then I'm going to call this curve, right? I'm just going to call it y. Remember, it's defined parametrically, as we can see, but I'm just going to call it y. So we are here. This is the answer, essentially. Does that make sense? Yeah? Okay. So now we need to figure out what the limit is, that upper limit. Now, if you think about it, right? Oh, by the way, where should I do this? You know what I'm gonna do? I'll get the limit in a second. But remember, we're dealing with a parametric integral, right? So we need to integrate that curve there, and it's defined parametrically. Remember, the formula for parametric integration is gonna be the integral of y dx d theta in this case, because we're dealing with theta d theta. That is the integral of that's the formula for parametric integration. So let us, before I'm going to get x2, I'm just going to do this first, right? So what do we have here? Well, I need y, which is 6 sine squared theta, that. And then dx d theta is something we already calculated. What was it again? Let me get, dx d theta was, where is it? Right there. It was right there. Let me copy that and get that. That was dx d theta right there. So I'm going to paste and put that there. That is dx d theta. And so that means if I copy that there, that can go right there and put a bracket around it. So we're timesing these together like that, d theta, right? This is our integral that we need to calculate. Now, obviously, we need limits though, don't we? I remember the area of S is two parts. It's the area of that one there and that one there. So what I'm gonna do, what should I do first? I'll do the harder part first because it's hard, and I'll do this integral at the very end, right? So we've got 6 sine squared theta minus 24 sine theta cos squared theta d theta. I remember we need the limits here. Now remember, this is parametric integration. So what I'm going to do, this is what I like to do when I'm dealing with integration, right? Is what I'll do is let me get this limit actually. I'll get this limit. That limit there is going to be when y is equal to 0, no? I have a curve here. The x-intercept is when y is 0. So I could figure out what y is. I could figure out what x is at the point by making x 0. No? Sorry, by making y 0. I could find out what x is by making y 0. Find the value of theta and plug it into the x value. So what I'm going to do to find out x2, I'm going to say just here, x2 is where y is 0, is when y is equal to 0, like that. Yeah? So if that's the case, remember, well, y was equal to 6 sine squared theta, no? Let me just double check. Yeah, it was equal to 6 sine squared theta. So I'm going to solve 6 sine squared theta is equal to 0. That means that sine squared theta is equal to 0. And that means that sine theta if I square root is going to be equal to 0. Like that. And that means, well, theta, if I take the sine inverse of that, I know that that's 0 to be fair. Yeah, sine inverse of 0 is 0. Theta is 0 to make this 0, right? So theta is 0. So what I'm going to do now is I'm going to plug that into my value of x, right? Or my parametric equation for x, which is x equals 8 cos cubed theta. So I'm going to say x2 is going to be, well, x is equal to 8 cos cubed theta, right? And we figured out that x2, right, is when y equals 0, and that's when theta is equal to 0. So we're just going to plug in theta equals to 0 to figure out what that limit is, like that. And that's going to be x is equal to 8 cos, and all right, like that. And then working that out, well, to be fair, I know that that's just the same as cos 0 all cubed. And that's just going to be, I know the cos of 0 is 1. So it's going to be 8 times 1 cubed, which is just 8. So therefore, x2, that upper limit is equal to 8. So essentially what we're doing here is that we've actually figured out that's equal to 8 right there, like that. So I'm going to rub this out. I'm going to put this here, like that. So remember, remember, this is a show that question, by the way. So what I'm going to do, I'm going to grab this here, like that. I'm going to copy this here. This is the area that we figured out, right? That there. I remember we're trying to show this. We're trying to show, where is it? Where's the show that? Right here. Copy that. And then what I'm going to do, let me just check the chat just to see that we're all good. Okay. Whoops. Do I get the chat? Oh no. Show chat. Okay. Right. Cool. Cool. So, anyways, you guys are trolling. You guys are trolling. Anyways, cool. So you've got this. This is what we need to work out. We need to show that we get that right. Now, remember, what do we have? Well, what we could do, yeah, I said I was going to do the harder part first. I'll do the harder part first. So we need to figure out what this is, don't we? In terms of theta, don't we? I remember we had this here. Parametrically was equal to this. So what we need now, we need to figure out the limits of integration. Thank you very much, Alu. I appreciate the £2. Thank you very much. Thank you so much. And then now, yeah, we need to. I'm going to do this part. So there's two parts. Remember the area of S, which is what they're asking us for. Let's get the picture just to just get again. Sorry, this is a long question. I'm just going to copy this here. Copy this here, just so it's clear, right? I just don't want. I should make sure that we get this correct, and it makes sense. So yeah, remember the area of S is two parts, right? It's this part here, number one, plus that part there, which is number two. These two areas here, and then this is number one right here. That's number two, right? Now we need to figure out what these limits are parametrically. So what I like to do when I'm dealing with parametric equations, right, is remember if I'm integrating parametrically or in Cartesian form, they have to be equivalent. So what I'm going to do here is I'm going to say, well, I've got 1 to 8, and then this is y dx, right? This is the Cartesian form, right? This is the Cartesian form, right? And then the parametric form I have right here. Let me write here, to be fair. Let me copy this here. No, let me put this here. That's the parametric form, right? But remember, we need corresponding limits now, parametric. So how do I get those limits? Well, we know that this is x is equal to 1, right? And we know that this is equal to 8 right here. So what we need to do, I think I've got in a circle to be fair, because I don't think I need to do, anyways, we'll see. So remember, if I'm dealing in the Cartesian form, this is when x is equal to 1, right? This is when x is equal to 8. And I know that x is equal to, what was x equal to parametrically? 8 cos cubed theta. So I need to figure out those values of, I need to figure out what that is. So I'm going to write this here. X is equal to 8 cos cubed theta, like that. And then now I need to make it equal to 1 and 8 to figure out the values of theta to then put into my limits. So if I do, I'll do the lower limit first. So 8 cos cubed theta, like that, is equal to 1. That means that cos cubed theta is equal to 1 over 8. And then, well, I need to cube root that. The cube root of 1 over 8 I know is a half, to be fair. That's equal to 1/2. I remember, by the way, what was theta between? Theta was between 0 and pi over 2, right? In the right square. Theta is between 0 and pi over 2. So what I'm going to do is I'm going to take the sine inverse, sorry, cos inverse, and see what I get. Cos inverse of 0.5, that's pi over 3. So that means that theta is equal to pi over 3, like that. Now, remember, that is going to be our corresponding limit here. So that's going to be pi over 3 right there, like that. Now, we need to get the upper limit now, and that's when x is 8. So I'm going to solve 8 cos cubed theta is equal to 8 to get the value of theta, right, when x is 8. So doing that, I'm going to divide through by 8. That's going to give me 1. If I divide both sides by 8, taking the cube root, that's going to be 1. I need theta. What is the value of theta when cos theta is 1 between 0 and pi over 2? That's just 0, no? If you think of the graph, but I'll just put it in. Cos inverse of 0. Let me put it in. Gives me pi over 2. Hold on, have I done something wrong? No, I know what I've done. I put 1 here. I need to put 1 there. And that gives me 0. Right. So yeah. So we've got our two limits now. So that means that I've got this here. So you may be thinking, right, that, well, what do we have here? We've actually got an integral, right, whereby the limits, the upper limit is smaller than the lower limit, right? Now, don't ever panic if you see that, right? There's something that you can do here. And this is something you can just remember for tomorrow, just in case it comes up, right? I'm going to put this here. This is something you just need to remember, right? If, for example, I'm going to write this here. You can just remember this. If you have an integral between a and b of f of x, right, dx, then this is just equal to minus the integral of a and b, like that. Now, you don't need to prove this or anything. You just need to remember it, right? If you've got a negative and the limits are reversed, you can take off the negative and flip the limits. So that's just something to remember. Please remember that, just in case that comes up. Yeah. So what we could do here as well, we've actually got a negative here, don't we? We've got a negative here. So what we can actually say is we can remove that, and that becomes I over 3, 0, and then it just becomes 6 sine squared theta, like that. And then it's going to be 24 sine theta, sine theta. Oops. I've been on this question for ages, to be fair. It's a long question. Like that. That's just something to remember. Yeah? All right. So now, let me just check. Cool. Anyways, so now we've got that here. Remember, this is a show that, by the way. Let's not lose sight of our show that. Remember, we need to show that the area of that, the area of S is equal to 4 plus 144 of that expression. I'm going to get that there. I remember, let me just grab everything that we need because we're actually nearly done now with this question anyway. Like that. So, putting this in, what do we have? Well, we've got this now, and I'm going to tidy this up like that. So if I tidy that up, well, what do I have here? Well, I've got, for example, I've got a 6 times 24. What's that? 6 times 24 is 144. So that is a constant that can go on the outside. So I can say this is 144, and it's going to be the integral of 0 and pi over 3 of all of that, which is going to be sine squared theta, and then it's going to be sine theta, cos squared theta, d theta, like that. Now, look at the show that, by the way. Remember, there's two parts to this question. Let me just get the other part just so we don't lose sight of it. Remember, this was the integral of that trapezium, isn't it? That line. We still need that part, by the way. I'm just going to put this here because we're nearly done. We're nearly done with this question. So now, let's look at the show that, though, because we've got the 144. That's fine. We haven't got what they've got, though. Right? Let's just tidy this up a bit more. I've got 144, like that. Oh, by the way, I forgot the pi over 3. Sorry. Like that there. And then that's going to be 0 pi over 3. And then I can write that as sine cubed theta, like that. And then cos squared theta, right? Let me just make sure, yeah, d theta, like that. Now, if I compare that with the show that, let me just get one more time and put it on the side. Now, for me, when I look at that, right? If I look at that integral there, I've got a sine cubed, and they don't have cubes. They've actually got squares, and they've got a sign there, right? Now, if you ever see something like this again, right? This cube, because I've got squares there, you can actually just rewrite this, right? To be fair, I shouldn't have done that, to be fair, because I could have just done it there. I've just gone backwards, but it don't matter. Anyways, you can write this as 144 pi over 3, like that. And then I've got 0, and then I've got, I can write this as, I'll write like this, sine theta, like that, and then sine squared theta. So I've just done the same thing. I didn't realize it was already like that. And you got that there. But remember, we need a cos to the 4. So what we could do is we could actually rewrite this as 1 minus cos squared, can't we? So I can write 144 and then pi over 3 between 0 is going to be sine theta. And then cos squared is 1 minus, sorry, sine squared is 1 minus cos squared. So I get that there, like that. And then I get cos squared d theta, like that. And then what I can do now is, well, that's good because I can now expand that. So I'm just going to write this now as 144 to equal of 0 pi over 3. And that's going to be sine theta cos squared theta, like that. 1 minus cos squared theta d theta, like that. Now look at the show that. All we need to do is expand now and we're done. Let's put this here, like that. So now, yeah, that's perfect because we actually get that, don't we? So we can say that we've got 144, like that, integral of 0 and pi over 3. If I expand this, then that's just going to be sine theta cos squared theta, like that. And then if I expand this one, well, what's going to happen? I'm going to have a sine theta there, and then I'm going to have cos to the 4 theta, like that, d theta. And that is that part done of the show that. Where's the show that? The show that was 4 plus that. Remember? So we've got that part. That was the hard part. We've done that. Remember the actual integral itself. Let's go back. It was the integral. We had to get these two parts. We've done the area of 2. We've done that. We need the area of that, which we said is the integral of, where was it? I think I had it somewhere. Where is it? This one right here. Remember, this was S, by the way, like that. So now all we need to do is just work out that part. We need to just work out that part right there. And that's easy. We need to just work out this part here. That's easy. That has to be 4. So if I integrate that, that's going to be That's going to be x squared over 2 plus 3.5x, like that, between 0 and 1. Now, if I plug that in, that's just going to be 1 squared over 2 plus 3.5, and then minus, and then that's just going to be 0, isn't it? Because that's 0 squared plus 3.5, and then 0. So it's just going to be whatever that is, and I'll put that in, and that's going to be that's 4, isn't it? Because I'll do it. 1 squared over 2 plus 3.5 is 4. So we get that 4 there. So therefore, we can say that therefore the answer for S is going to be equal to, remember we said it was equal to that integral there plus that one there, which we found parametrically. It's going to be 4 plus, and then I'm just going to copy that to be fair, all of that there. So we get it. So that was a very long question. That took me ages. But yeah, does that make sense, guys? That was the question, and that will give you 6 marks. Obviously, I'm explaining it to you guys, so I'm sure you guys will do it a lot quicker in an exam condition. But yeah, hopefully that makes sense. Yeah, this is just for getting skip. Nah, Dylan, you're not skipping nothing. You're not skipping nothing. But we all good? I'm just checking. Bro, this is some skip. This is so long. I know, Lexine. I know, Lexine. All right. Okay. Yeah. If I just did this question in 5 minutes, him explaining it makes it a bit long. Yeah, I'm explaining it. My mood. My mood. Yeah. But when you guys do it yourselves, you guys will do it quick. Yeah. It's because obviously I'm explaining it to you. I'm just making sure that you get every single step. So yeah, let me just make sure there's nothing working. I'm not frozen on my. All right, cool. So we've done that. And then now, 30 minutes, Daniel. As in, should I leave in 30 minutes? Is that what you're saying? All right, my hair's turning grey. Sorry. It's done. All right, now we got that there, and then that's done. And then now part D says hence by integration find the exact area of S. So doing that, let's do this one. So we've worked that out. We've got this here. So whoops, where is it gone? Hold on a second. Let me get it again. This is not working. Let me get S. Okay. So S, hence by integration, find the exact area of S. Let me copy that one more time. Hopefully that should work. Okay, it does. So if I do it again now, we need to find the exact area of S. So we just need to work out what that is. So we need to work out what this S is now. So we need to integrate this essentially. Yeah. Now, how do we integrate something like this? Uh, you've got to use the reverse chain rule because if you look at these here, right? If you look at these here, like that, it's of the form where I've got a derivative, cos differentiates the sign, and we've got a power here. So I actually did this before in my life, right? But yeah, this one I'm gonna do it bit by bit. So for example, I'm just gonna say, well, it's gonna be 4 plus 144, and I'm gonna put a big bracket on like this. And I'm gonna just work this out. So I'm gonna do it separately. So what I'll do, or you know what I'll do, yeah, I'll just do that and I'll write like that. Now first I need to integrate that there between 0 and pi over 3 of that. So sine theta cos squared theta, like that. I'm going to integrate that, d theta, separately, and I'm going to do that one, like that, separately as well. Pi over 3 of sine theta cos to the 4 theta, d theta. How do I integrate that? Well, firstly, integrating that, what you're going to do is this is of the form f dash of x and then f of x to the power of n. And when that's the case, right, you have to just basically, it's like a guessing game, yeah? Obviously the actual formula as well, by the way, is that I'm gonna say try, you're gonna say y equals f of x to the n plus one. You're gonna increase the power of whatever this is here with the power. So in that case, I'm gonna let y equal cos cubed theta, like that. And then what I'll do actually, I'll write it in a bracket like this. So this will be like that. And then that way, it's gonna be if I differentiate, it's gonna be dy over d theta is going to equal 3 cos theta all squared, like that. Drops 1, it's going to be minus sine theta. And now if I tally that up, right, well, that means I'm going to have, well, minus 3 sine theta cos squared theta. So now if somebody asks you to integrate that, someone asks you to integrate that, sine theta, like that, cos to theta d theta, well then I know that that's just going to be that because I just differentiated that and I got that. So if I integrate that, it's going to cancel it. So it's going to be equal to cos cubed theta, right? So if that's the case, remember our integral is without the 3. So it's actually integrating this. We're actually integrating sine theta cos squared theta d theta, right? Now, what is the difference between these? We're just divided by minus 3. So it's just going to be divided by minus 3 here. Minus 3. So therefore, it's going to be minus a third cos cubed theta. That's it. Obviously plus c, but we're doing a definite integration, so I'll just leave it like that, right? So minus a third cos cubed theta, right? And then now, what I can do then is say, well, just doing that then, that's going to be, I'm going to say, well, it's going to be 4 plus 144, put a big bracket around it. And I know that that just becomes minus a third cos cubed. Let me do it like that to be fair. So let me zoom in. Minus a third cos cubed theta, like that. Minus a third cos cubed theta, like that. And where are we? Where are we? We are here. Yeah, we're there. So that's fine. That one's done. And then I'm going to do this one here. It's the same thing, to be fair. So if I do that one on the right, we can see that just based on what I've just done there, if I want to integrate that there, well, I'm going to try, I'll do this one here. I'm going to increase that by 1. It's going to be try y equals cos to the 5 theta. Differentiating that, that will give me 5 cos theta, like that, to the power of 4. And then we're going to times by minus sine. So if I tally that up, it's going to be minus 5 sine theta cos to the 4 theta. So again, if somebody asks you to integrate that, you'd get that, wouldn't you? You'd get cos to the 5. So if somebody asks you to integrate that, which doesn't have a minus 5, like that, theta, let me just make sure I've done that correct. Yeah, that's fine. Yeah, without that, so it's going to be cos of to the 4 theta d theta. That's going to be, well, the difference is divided by minus 5, no? So it's going to be minus a fifth cos to the 5 theta. So now we've got the integral for both. Yeah? Yeah? Cool. So now, all we can do is, let me just make sure I'm not glitching anything. Okay. Okay. I think I'm fine, to be fair. All right, cool. Yeah, I'm good. I'm good. So now, we can just bring these together now because I know what that integral is. So let me copy that and bring this all together here. So we've worked out that. So it's just going to be now, copy that there. I'll just copy this here. And that means it's just going to be, well, we know that it's going to be 4 plus 144, like that. And then it's going to be, in a bracket, we're going to integrate. We've integrated now. That one, we know was minus a third cos cubed, like that, theta. And then minus, and then I'm going to put a bracket around it here. And then the integral of the other one was minus a fifth cos to the 5. So we get that there, minus a fifth cos to the 5 theta. And then this is all between the limits of 0 and pi over 3. So that should be it. Hopefully I haven't made a mistake. Hope so. Hope not. Yeah. So yeah, we've got that now. So all we need to do is just, let me just put this 4 plus 144. Now that. And then it's going to be, that there's going to be a plus, isn't it? So I can actually write, I'm going to write it this way. 1 over 5 cos to the 5 theta minus a third cos to the 3 theta, like that. Like that, and it's going to be 0 and pi over 3. So we're nearly done. Then now I need to just work that out. So it's going to be 4 plus 144, all in a big bracket, and I'm going to evaluate this now. So it's going to be 1 over 5 cos pi over 3 to the power of 5, like that, minus 1 over 3 cos to the pi over 3 to the power of 3, right? That's going to be the upper limit, and I'm going to take away the lower limit, which is going to be 1 over 5 and then cosine of 0, sorry, to the 5, like that, and then minus 1 over 3 and then cosine of 0 to the power of 3, like that. And then now we're nearly done. 4 plus 1, 4 bracket, and then I'm gonna put that in my calculator and see what I get. So that's gonna be 1 over 5. I'll do it here. I'll do this part here. 1 over 5 cosine of pi over 3, like that. And then this is all going to be to power 5, like that. And then I'm gonna, let me make sure that's all good. Yeah, that's good. Take away minus 1 over 3. Whoops. Minus 1 over 3. And then cosine of pi over 3. Pi over 3 all cubed, like that. Cubed, like that. And what does that give me? Let me just make sure that's all good. Got that there. That's fine. No brackets needed there. Yeah, that's fine. Equals, that gives me minus 17 over 480. Minus 17 over 480, that will give me that part. And then minus, and then that one, well, I know that that's going to be, cos of 0 is 1. This is going to be 1 over 5, minus 1 over 3, right? Because cos of 0 is 1, yeah? And then now, I've got 4 plus 144 of all of that. Now, let me just do that. That's minus 17 over 480 minus, and then what's that? I'll just put that in my calculator. 1 over 5 minus a third is minus 2 over 15. So plugging that in now, I can just put that all in. And hopefully that gives me the answer. Let me do it in bits. So it's going to be minus 17 over 480 minus, and then a minus 2 over 15. Hopefully this is correct. 47 over 80. So it's going to be 4 plus 144. 47 over, what is that? 480. So that way it's just going to be whatever that is. So it's going to be 4 plus 144 times answer, 181 over 10. I can't believe I got that correct. I remember that's the answer that I got when I saw this earlier today. Wow. Done. That is the answer. Does that make sense? Hopefully I haven't, hope you guys are not sleeping. Oops. Cancel. Yeah? This question is outrageous. It's not, is it me? I know I take long to explain things. So is it me or is it the question? Bro, it's still yapping. Sorry, man. Sorry, man. Okay. Cool. Cool. Right. 20, 20 minutes per month. I'm so sorry, guys. I'm so sorry, guys. I'm so sorry, guys. But does that make sense? That's a joke. 2 hours later. Yeah, I won't be doing a long question like that again. But but yeah. Cool. Let me just see. Be faster. Yeah, this question, yeah. So I was sneezing. I can't go over that again. I'm sorry, that's too long. I'm even shocked I got it correct, not making any mistake. Dan, did you get extra time? I didn't. I didn't, to be fair. I know I take long to explain things, but yeah. But cool. So that's done. How long has it been? It's been an hour and 42. What are we thinking, guys? I said it was gonna be about 2 hours. Have I bored you? Have I bored you? Want me to keep going, or what do you think? Okay. Dan, say Lila, please. Lila. I'm just reading. Okay, okay, okay. Cool. You're lying. You're lying. Hold on. Is my mic not working? Okay, keep going. Okay. All right, cool. Cool. All right. I did vectors on Saturday. I'm gonna see. Okay, I've got a couple more questions, right? All right, cool. Make it 3 hours. That's Love Island's on in 18, to be fair. No, I'm checking, I'm checking. All right, cool. Make it 4 hours. All right, cool. So you've done that. I've got a couple more questions. So, yeah, got this one here. Recurrence relation. So this is another one. So I've got the circles. Or should I just? I'm just thinking. I haven't got a circles question, to be fair. I did circles the other day, to be fair. Trig, modeling, implicit. Okay, you know what? I have got an implicit one, to be fair. So I can see a lot of implicits. I'll do that. I'll do that. Yeah? 24-hour stream. All right. Cool. All right. Let's see. All right. We'll do this one, yeah? Man, that's easy. Skip it. Let me just see it. What this? Is this calm? Is it implicit calm? Is this calm? Yeah? No more integration. All right. Okay. This is a good question, yeah? All right, cool. Cool. This question is like, all right, cool, cool, cool. What I'll do is I'll do it, and then after you guys can just ask me some questions and maybe topics, and maybe I could just explain some things to you guys. Yeah? All right. So, all right. Prove by using logarithms, right? That d dx, the derivative of 2 to the x is equal to 2 to the x ln 2, right? So, how do we do this? If you ever see this, by the way, if you've got y is equal to 2 to the x or even x to the x or anything to the power of x, right? What they want you to do is you make it equal to y first, and then you're going to take natural logarithms, right? Nah, so yeah, I'll do it quick. I'll do it quick. Okay, I'm going to do this quick. I'm going to do it quick. I'm going to do it quick. So therefore, I'm going to take the ln of both sides. So it's going to be ln y. It's going to be the ln of 2 to the x. I'm going to do it quick. And I want you guys to tell me if I'm being too fast. So now, what you want to do, your log laws that x drops to the front. It's going to be ln y is going to equal x ln 2, like that. And then remember, you want dy over dx, by the way, because you're differentiating this. So what we need to do is differentiate implicitly, don't we? To get dy over dx. So first, if I differentiate that implicitly, I need to differentiate that normally. That's going to be 1 over y, like that. Dy over dx. Remember, you times by dy over dx. And then we're going to get x ln 2 here. No, sorry, no, we're not, because we need to differentiate that. If I differentiate that with respect to x now, that's just going to be, remember, this is the same as, all right, here, ln2 is a constant x, right? If I asked you to differentiate 4x, you would just tell me it's 4, right? The constant. So this one has to go to a constant ln2. So I'm going to put ln2 there, like that. And then now, dy dx, remember, is what we're looking for. If I rearrange that, that's going to be dy dx is going to equal, hold on, dy dx is going to equal y ln2, like that. Now, remember, we're looking for dy over dx. We need to show that it's equal to 2 to the x ln 2. We've got that there. But remember, at the very beginning, we said y is equal to 2 to the x. So therefore, we can say since y is equal to 2 to the x, that means that dy dx is equal to 2 to the x ln 2. That's quick. That was quick, right? Or no, I don't want it to be too quick. Oh, is it too fast now? Is it too fast? Put polls in the chat so people can vote. How do I put polls? I don't know how to put polls. I'm new to this live streaming thing. Oh, engage with your audience. Oh, start a poll. Oh, right, I can start a poll. Let me put something in the poll. Let me put something in the poll. Um, uh, is it? Hold on, hold on. Let me see. Let me see. Cool. I've just put something in. I've just put a poll in. You guys are funny. All right, cool. So that's done. Okay, 93% facts. Am I not the goat? No, I'm joking. I'm joking. Anyways, so that's done. Part B says the point B with coordinate the point P with coordinates 2, 0 lies on C. Also, I even missed a part of it. The curve C has the equation 2x plus 3y squared plus 3x squared y plus 12 is equal to 4 times 2 to the x. The point P with coordinates 2, 0 lies on C. Find an equation of the tangent at P. Yeah? So, uh, you guys are funny. Anyways, let's do this one. And then I think it's yeah. I think I'll finish this one. I'll give you a chance to ask the questions and then finish that one. So we need to find the equation of the tangent, right? So to find the equation of the tangent, you need to differentiate, obviously. Now, obviously, this is not in terms of x or y, so we need to use implicit differentiation. So this one is going to be all right here, 2x plus 3y squared plus 3 squared xy. 3x squared y, sorry, plus 12 is equal to 4 times 2 to the x. And we need to differentiate with respect to x as we go along. So this one is going to be 2. If I differentiate that with respect to x, I'm just going to write d dx here, so we know we differentiate with respect to x. This one we need to do implicitly because it's going to be 3y squared. It's going to be 6y, and it's going to be dy over dx, right? And then this one, this is a product of two different functions. I need to use the product rule here. Yeah? You just put this here. Why does 2 to the x equal y, please? So we just, it's just something to just make it equal to, just so you could find the expression for dy dx. So you can remember, in maths, you can make anything equal to anything. So the reason why we made y equal to dy over dx, sorry, the reason why we made y equals 2 to the x is just so we can have something as, we could just write as a function, yeah? So we can figure out what dy over dx is. It's the same thing, yeah? Do something harder. This is year 10. Okay. Uh, all right, cool. Let me just finish this. Let me just finish this. And then now, product rule. I need to use this here. It's gonna be 3x squared y. I'm gonna call this u, 3x squared. I'm gonna call this v y. And in doing that, that's gonna be du over dx. All right, u dash to be quick. It's gonna be 6x here. V dash is gonna be equal to 1 dy dx, isn't it? If I differentiate that and then times by dy dx. So it's gonna be uv dash plus vu dash, like that. So that's gonna be 3x squared dy over dx plus these two, which is just gonna be 6xy, like that. And that's gonna be the product rule done. Let me just double check. Yeah, that's fine. 3x squared y. Yeah, that's 6x. That's fine. Yeah, that's fine. That's fine. So that way I'm gonna put this there. I'm gonna put that there. Copy that and put that there. And that will be there, like that. And then plus, that's that one done. And then plus, and I need to do that. That goes to 0. So there's going to be nothing. That's going to be equals 0, plus 0. I'll remove it in a second, just to be clear. And then this one, remember, we already worked out what this is. 2 to the x differentiates to 2 to the x ln 2. So it's going to be 4 times 2 to the x ln 2. And that is going to be our derivative here. Does that make sense, guys? Are we happy with that? Move this here. All right. Cool. So done that. And then now remember, we're looking for the equation of the tangent. We need to figure out what the gradient is, obviously. So let's just tidy this up a bit. That is going to go. I don't need to put that there because it's going to be 0. So I can just move this here. And then now what are we looking for? We're looking for the tangent at the point where y at the point 2, 0. So remember, by the way, that's going to be y minus y1 is going to equal mx minus x1. So what I'm going to do is I'm going to figure out what dy dx is. And we know what the point P is, which is good. Point P that we're looking for is 2, 0. So that's fine. We need to figure out what the gradient is. All right. So doing this, what I'm gonna do, I'm gonna move everything from left to right that hasn't got a dy dx on it. So it's gonna be 6y dy over dx, like that, plus 3x squared dy dx. And this is gonna equal, I'll put this in a bracket so it's clear. 4 times 2 to the x ln 2. And I'm gonna minus, what am I gonna minus? I'm gonna minus that 2 and that 6xy. Minus 2 minus 6xy. That's gonna give us that. And we're gonna now factor out the dy dx, aren't we? To get dy over dx, bracket 6y plus 3x squared is equal to that there. I'll just copy that. Just like that. Copy there, put it there. And that will go there. And we're just gonna divide by that there. So we're gonna have dy over dx. We're gonna have dy over dx is equal to just that divided by that. So I'll just do this here to be fair, instead of writing it out. Copy that there, paste that there, and then we're going to divide by that there. So it's just going to be that. It's going to be that. 6y plus 3x squared. Does that make sense, guys? You happy with that? Just make sure. Let me just make sure I'm just checking the chat. Okay. Cool. So I think this is all okay then. Okay. No, it's all good, Sam. It's all good, Sam. It's all good, Sam. And yeah. So now, remember we need dy dx, and that's where p is at 2, 0. So we need to plug in x equals 2 and y equals 0 into all of that to see what dy dx is. So I'm going to do this. It's going to be 4 times 2 to the 2. You need to be careful, by the way, ln 2, like that. And then it's going to be minus 2, and it's going to be 6, 2, and then 0, like that, over 6 lots of 0 plus 3, 2 squared, like that. So hold on, this is a bit, let me just tidy it up a bit. It's gonna be out there. It's gonna be 6 lots of 0, sorry, and then plus 3 and then 2 squared, like that. So now, tidying that up, what's that gonna be? That's gonna be That's going to be 16, no? 4 times 2 squared is 4 times 4. That's 16 ln 2. That there is minus 2. That goes. That's 0. And then this is over what? What's that? 2 squared is 4. 4 times 3 is 12, no? So the gradient of the tangent is 16 ln 2 minus 2 over 12. So we've got that there. And then they didn't ask for any specific form, to be fair. So we can just say then that's going to be that there. And then remember, this is what we've got here. So we could say that, remember, the point P was 2, 0, wasn't it? So plugging everything in now, it's going to be y minus 0 for that. It's going to be 16 ln 2 minus 2 over 12. And then it's going to be x minus 2. And that is just the same as y is equal to 16 ln 2 minus 12. Sorry, I put a 12 there. My bad. It should be a 2. It should be a 2 there. And then that should be over 12 and then x minus 2. And that's it. Does that make sense? Okay. So, Umar and Mimi, Umar and Mimi, you guys are funny. You guys are killing me. But yeah, does that make sense? Are we happy with that? Let me just make sure I got that correct, by the way. I'm just going to go on my other page with my solutions to make sure I got that one correct. But yeah, that looks right to me. Where did I do it? Implicit, right there. What's the answer? Um, Implicit. Yeah, that's perfect. That's done. That's done. And that is about 2 hours, guys. That is about 2 hours. So what I'm gonna do now is yeah, I have the month scheme. Yeah, I do. I do. I think I've got the link on my OneDrive. What I'll do is I'll put in the description after. But yeah, that's pretty much it. That's what I've got for you. Hope that's okay. Any questions I didn't get to do, I'll put a link and you can try them yourselves. And I've got the written solutions as well. So yeah, what I'll do just before we go, does anybody that have any questions about tomorrow? Just anything that they just want me to quickly go over, anything like that? Emu, I did vectors the other day. I haven't got any more vector questions that I've actually looked at and I know how to do off the bat. Sorry, man. Okay, let's just see. Let's just see what we've got here. I'm just having a look here. Let's click from. You leaving us for Love Island now? No, 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 no. Damn, my God, let me just see. Whoops. It's 12 a.m. here. Stream tomorrow morning at 7 a.m. Should I stream tomorrow morning at 7? I'll be sleeping. Okay. Yeah, best tip for tomorrow. I would just say, nah, I'm not watching that, man. I don't watch that. I don't watch that. But anyways, yeah, best fits. I've actually got something for you, by the way. I've got something. Formula sheet. So remember, stationary points. If you see stationary points, that just means that dy/dx is equal to 0, right? So if they ask you for a minimum point, a minimum turning point, that just means you just differentiate and equal to 0. That's all you need to do and then solve. And obviously you've got the chain rule here. Remember, you'll be able to stop this. This is just the chain rule, how it works. This is also good for the connected rates of change problem that could come up, that didn't come up on paper one. And yeah, as well as that, what else is there? You've got your log laws here. Make sure you know these off by heart. Super important. I don't think logs came up in Edexcel in paper one. So make sure you know these off by heart. Integration formula sheet. These are standard integrals that you should know off by heart, guys. Yeah. So what do we think about these integrals? We all know these. Put 10 if you know all of them. Put 0 if you don't know any of these. Yeah. I've got a vectors question I did on Saturday. So DRKC. If I don't know if you've seen that, but yeah, I've got one. Where's the link to this? No, 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 no. Then what does continuous mean? What rewrite that, bro. What does continuous mean? I think what you're talking about. Let me just see this. Somewhere in the formula book. Okay, good. So yeah, make sure you know these. That's good. And yeah, as well as that, remember if you differentiate ln of f of x. So for example, let's say you had yeah, we've actually got this one example here. Didn't even know what it is. Differentiate y equals ln of x squared plus 1. How do you differentiate that? Well, the function is x squared plus 1. Differentiate that, you get 2x, you just put them on top of each other. So just remember that. Yeah? How do you integrate tan x? I did this in my other live. I did it the other live. So what's that? Volatile. If you check the live I did on Saturday, I actually did it at the end. I've got the time steps as well. Yeah? So let's just see. Okay. Could you quickly go over if y is could you quickly go over if y is increasing or decreasing using dy dx? Okay, so if remember, if you've got a graph, I think this is actually quite helpful to be fair. This right here, if you look, if you visualize it, right, you've got a curve here. The graph is going downwards. That means that the gradient is negative. Remember, the gradient is defined as the tangent line. If the graph is going if the graph is going downwards, then the tangent line is going down. The gradient is negative. So if the graph is decreasing, it just means that dy dx is less than 0. If the graph is increasing, it means that the dy dx is greater than 0. So if they say, for example, show that f of x, f dash of x, show that f of x is increasing or something, or show that y is increasing, you would differentiate and then you just set an inequality, or you wouldn't actually. You would differentiate and show that your function is greater than 0 algebraically. Yeah? What does the second derivative tell you? Nil. It tells you the nature of your stationary point. So again, if you've got d squared y over dx squared like that, if you have a stationary point, right? Let's just say you figured out stationary point is when dy dx is equal to 0, and then you found, for example, x is equal to 5. Yeah? And then now, if you want to show, if you want to see, so right now, actually, this is a stationary point. We don't know whether it's a max or a min. What the second derivative does, it's like a verifier. If you plug that in and you get something greater than 0, right? That means that you're dealing with a minimum point. Yeah. If you plug in 5 and then you get less than 0, that means it's a max. So the second derivative determines the nature. What does differentiate mean, G? I'm not joking. It just means that you're finding the gradient of a function. Literally, differentiation is just the gradient of a function. Yeah? Okay. Is there a PDF, sir? Yeah, integral of 2 to the x is, yeah, the integral of 2 to the x is 2 to the x and 2. Because remember, we just figured out that y is equal to 2 to the x, right? And dy dx is equal to 2 to the x ln 2, right? So if they ask you to integrate 2 to the x, for example, well, we know that when we integrate 2 to the x ln 2, we get 2 to the x, right? All right, plus c, right? Just from there. So if they ask me to integrate 2 to the x without the ln 2, right? Well, I forgot the dx, by the way. What is the difference between these two? Well, there, to go from there to there, I have to divide by that ln 2, no? Because ln 2 is a constant. So therefore, it's just going to be 1 over ln 2 times 2 to the x plus c. Does that make sense? Points of inflection, that's when the second derivative is 0. There's actually a good part in the book, actually. Let me just see. If I go to, let me go to, hold on, let me go to A Level Books, year 2. Can I do that? Hold on. If I go to that there, I think it's in this book. If you guys got this book, that's helpful. Let me just see. How do you differentiate x? It's just one. Okay. Okay. How about the point of inflection? Let me get that up because I think there's actually a good it's when it's equal to 0 though. Your second derivative is equal to 0, and what you could do is you could test it by plugging in values of x either side of your stationary point to show that you get a point of inflection. There wouldn't be a change of sign if there's a point of inflection. Yeah. Okay. I'm just checking. And if I needed to use if I needed to find the second root of 2 to the x, do I use the product rule? Um, can we see the search history? It's all math stuff. It's all math stuff. Can you go for a question where we have to do first principles power 1 over 2? Change the sign. Then did you torrent the book? What does that mean? Golden Latias torrent the book. I'm not. One of my students told me put it on my Google Chrome. I don't know exactly what he did. What is the integral of sine squared 2x? Oh, that's another one to be fair. If you need to integrate sine squared, right? Then what you've got to use actually is you've got to use the double angle formula. So for example, let me think. Yeah, cos 2x, sorry, is 1 minus sine squared, 1 minus 2 sine squared. That's one of the identities, right? like that. Hold on, handwriting is terrible. So 1 minus 2 sine squared x, like that. And then now, if I want to rearrange that, I'm gonna have 2 sine squared x, right, is equal to 1 minus cos 2x. If I want to integrate that, and then if I divide by 2, I'm gonna get sine squared x is equal to 1 over 2 minus a half cos 2x. And this is good because we've got rid of that power, so we can write this like this: integral of 1 half minus 1 over 2 cos 2x dx, like that. And then integrating that is easy. That's going to be what's that? That's going to be a half x, and then that's going to be minus a half. How do I integrate cosine? That's going to go to sine 2x, and then we have to divide by the derivative 2x, like that, plus c. So therefore it's going to be 1 half x minus a quarter sine 2x plus c. That's how you integrate sine squared. Yeah. What happens if it's sine cubed x? Ah, I've forgotten that one, you know. That one you have to use. How do you do sine cubed? I've seen it before. Just check online. Just check online. Could I just use the reverse chain rule? No, you couldn't use the reverse chain rule because remember the reverse chain rule is whereby you have a derivative. So normally if it was like cos sine squared x, right? Like that, dx, then this would be a chain rule problem because remember, if I was like y is equal to sine all to the 3, sine x all to the 3, then that will differentiate to be 3 sine squared x, like that, and then cos x. And then can you see that there, if I integrate 3 sine squared x cos x, like that will just go to that, isn't it? That will just go to sine cubed, right? So you need to have it in this expression there. You've got something which is the derivative times by a power, right? If you've just got sine squared here, it's not going to work, yeah? So this one here, by the way, is going to be that's going to be sine cubed, right? So that one, I have to divide by 3 to get there. That's going to be a third sine cubed. Yeah? Let me just see what we've got here. And let me just see the chat. Okay. Can you do proof for arithmetic series? I've actually got that on my TikTok. I'll show you if I've got it on TikTok. Um, Oh, I'm on 4,000 followers. Wow. I appreciate it. But I've actually got it on my TikTok somewhere. I can't remember where, but I did it a couple of weeks ago. Yeah, right there. Arithmetic series is proof is right there on my TikTok. So you can go and watch that. And yeah, let me just see. Okay. Let me just see. Okay, cool. I think that's all good then. I think that's all good. Okay. Yeah, I think that's all good. Respect for plugging in TikTok. Cheeky flex. Nah, I'm just helping you guys out, man. I'm just helping you guys out. Okay. Ecstatic Auxiliary. Hi, man. I hope you're doing well. How to prove cos A plus B. Okay. All right. All right. So, yeah, I think we're gonna round up. I think we're gonna round up. Yeah, I can see a lot of questions. What you can do is maybe DM me or Google the questions as hopefully you can get them, yeah? All right. So, is my hair real? I saw somebody comment that the other day. Yeah, my hair is real. My hair is real to be fair. But yeah, I think we'll leave it there. What do I need to do? I need to go back to the scene. Hold on. How do I go back? I think I do that there, and then I'm just gonna go to big cam. Does that work? Yeah, I think that's all good. So I think you guys should be able to just see me now. Yeah, I think you guys should see me. Let me just check. Let me just check on my thing. Does that work? I'm just checking to see if you guys can see me. Yeah, I think you can, to be fair. Hold on. What's going on? Yeah, yeah, yeah. You can. Whoops. All right. So yeah, guys, I just want to just say, wish you the best of luck for tomorrow. You guys are gonna smash it. Yeah, just make sure you do everything that you've been doing, revising, keep doing what you're doing. Just got to sleep early. I think what I'm going to do is I'm going to do the timestamps for for this live before I sleep. So hopefully that should be done for you maybe in about an hour or an hour and a half. But yeah, I just want to just say thanks a lot for joining. And yeah, that's pretty much it. I'm just gonna just check I'm still live though, because my laptop's gone. Okay. Yeah. Okay, cool. Yeah, yeah. Guys, okay, it's W, yeah. You guys are all gonna get wins tomorrow. You guys are gonna get all your grades, right? So put W's in the chat. You guys are already putting W's. Yeah? Okay, cool, cool. All right then, guys. Take care. Have a good one. Good luck for tomorrow. Don't go to bed too late. Yeah? Let me know how it goes.